Today I'm going to take a look at V-mount batteries from two different brands, Neweer and SmallRig. The difference between these, as far as I can tell, is that one is made by Neweer and one is made by SmallRig. The SmallRig one costs twice as much, or thereabouts. I think right now on Amazon this is going for $200. This is going for about $110. So, is there a difference? Or can I get away with just buying the Neweer battery and not the SmallRig? You can see they look a bit different, but in the product photos, displays look similar. The form factor just generally looks very similar. I mean, they're V-mount batteries, the form factor is not going to be crazy different, but you can see even the boxes are extremely similar, although one's a little thicker than the other. And I mean, it makes sense because the batteries are going to be about the same size because they're V-mount batteries. It's a standard. Although, to be fair, it's a standard for the mount and the electrical connector, not so much for the size of the battery, because you can get small ones, you can get big ones. Point being, they have extraordinarily similar specifications. Now, they're both 14.5 volts, or this one actually is 14.54, which you'd expect from a V-mount battery. This is 6800 milliamp hour. This one is 6.7 amp hour, which is 6700 milliamp hour, so pretty much the same. This one's actually 14.8 volts. This one has a D-tap output, as does this one, and that output is rated at 14 amps max, so is this one, which I believe is pretty standard, but neither one shies away from that. So very, very similar. So my plan for this video is just briefly take them out of their boxes, see how similar they are. And Neweer is a brand I'm familiar with. I actually own a bunch of their products. They generally make cheap stuff, but functional stuff. You know, like, it's not super high quality, but usually get the job done. I'll buy something from them if it's something I'm not going to use frequently, that I don't need to be durable or reliable. It's for like a one-off. Do a tech... Oh. I was going to say I'll do a Techmoan style removal of the protective film, but, oh. It was stuck really well in the corner. So, shiny surface on the front. I'm not like a huge fan of the way it looks. It is very light, but this is one thing that drew me to these batteries, is that they have an OLED display showing, in this case, the overall battery voltage, 8 volt, 12 volt rails, USB-A and USB-C, and of course the overall battery percentage in a little diagram of battery, as one would expect. As for the SmallRig, you'll notice because their capacities were very similar. This one says 99 on it, and this one also brags of being 99 watt hours. It's come with stickers? Yeah, it comes with a whole suite of stickers. I guess that's where the extra $100 goes. I'm more or less well, I'm kind of kidding. I mean, not that it's much to go on, but you can kind of see the similarity, and even the protective film, which also the tab just rips right off. Yeah, the SmallRig one is physically smaller, even though the box was larger on that one, right? Yeah, the SmallRig was the one with the larger box, but the smaller battery. And like I said, they looked similar in the product listing on Amazon. I didn't dive into it too carefully because I just figured I'd just test them just to see anyway, because the price difference was so great. But they both have this shiny display area on the front. This one has a power button on the side. Oh, this one completely dead? Alright, well, on the top, it's got USB-C, USB-A, 12 volt and 8 volt barrel jacks. Let me turn that right side up for you. And I do believe it charges off USB-C. Take a very cursory glance at the manual just to make sure I'm not talking crap. Yeah, USB-C input/output. The D-tap is also an input/output, as is the BP input is also an output. I mean, the BP connector on the bottom is also input/output, so it should be able to charge off of a proper V-mount charger. I guess I should show the ports, because I'm going to have to charge this at least a little bit so you can see the display. D-tap there on the side. Cautions you to check the polarity. Now, incidentally, I've made this cable, which isn't going to be good for high amperage, but it'll be good for the battery discharge test. It's a D-tap to just spade connectors, positive and negative, labeled by color. And I did check it on another D-tap connector before, so we know it's right. And, of course, I showed you the ports on the top. For the Neweer, port layout's a little different, but it's got USB-A and C and D-tap. Let me go grab a... Actually, you know what? Before I grab a USB cable, I'm hoping a USB cable will not only charge the battery, but also power up the circuitry, so at least we can see the display on that guy. And as that front display is not, yeah, it's not backlit, but you can see it is charging the battery. Now, a couple of seconds have elapsed. Yeah, it's pretty dim, so I had to boost the gain quite a bit. But yeah, and now it's at 1%, and it's got a little charging icon there. And I wonder if that is enough to at least get the display to show what the display will show. Does this just show percentage? Now I'm curious to see if it'll say anything different if I plug it into like a USB-C power supply. No, it's just got the blinking 2. Yeah, see, OLED digital display. It should show that information. That's all the same information that the Neweer is showing, just formatted slightly differently. But then in the other pictures, it always shows just a percentage and not all that information. So, okay. So it doesn't act like the Neweer does. So it says, when turn on the battery without any operation, the percentage of battery juice will be displayed. They use the term juice, which is fine. When discharging, it will display the voltage of input-output port, the battery juice, and voltage of the battery. I guess battery juice they're using as battery percentage. When charging, only the screen displays the battery level. When charging and discharging at the same time, it'll display all this crap. And then this is if the discharge is limited. When the USB-C port is abnormally charged. Okay, so that's overcurrent. That's overcurrent on a particular output. That's overcurrent in total. And then if the temperature is above 45 degrees C or 113 Fahrenheit during charging, only during charging, it'll flash that. Okay. Yeah, that was my fault for assuming that these were so similar that they would behave the same way, even though they are incredibly similar. All right, that's my bad for getting ahead of myself there. What I'm going to do right now is just hook up the electronic load. And to the electronic load, I have a USB-C connector, so we can just put this under a slight amount of load. The battery is extremely low, so I'm just going to take 0.1 amps or 100 milliamps, connect that to the USB-C port, and then turn the output on. Okay, it is putting out 20 volts. Huh. Did I ruin this thing's day? It's still just showing the software version. I honestly don't know what I did to get it to show that. If you hold it down for 3 seconds, it should turn the display off. But I don't think it'll turn the display off while it's charging. Hey, there it goes. Don't know what I did, I just pressed everything. Well, I pressed it a whole bunch of times. And it's a very flickery display on camera. But we got the USB-A on top at 0 volts, USB-C outputting 20 volts, DC1 and DC2, which would be the 12 and 8 volts. Battery's at 6%, and it's outputting 13 volts. Or maybe that's the voltage of the battery pack. Actually, I guess let's see what the voltage coming off the D-tap connector is. Yeah, and so there's 13.1 volts coming off the D-tap connector, and it is showing, you can't even see it, it's showing 13.0 volts on the display. Which, fair enough. We can stop discharging. So yeah, I'm sure you can understand why I found these to be, I don't want to say suspiciously similar, because it's not a problem if they're similar, but it just was weird to me that they had such a similar design and similar specifications and similar inputs and outputs. Yeah, again, barrel plugs, different locations for the connectors, although the D-taps are in the same spot. Oh, this one's actually lower in the case than that one. And this one has, of course, USB on the side. And one other thing that's not... What the hell? And one other thing that's not conclusive, but kind of gives an indication, is the weight. Because, batteries store electrical energy as chemical energy. So generally speaking, the heavier the battery, the more energy it will store, assuming it's of the same chemistry as another battery. Because the more electricity you want to store in here, the more chemicals you need, and the more attendant components to support those chemicals. 565 grams for the SmallRig, and 605 grams for the Neweer. Now, of course, I'm not just weighing the batteries themselves, I'm weighing the case, the V-mount connector and all that stuff, and whatever circuitry's in here, these flappy things. So I'm not just measuring the batteries, but they do weigh a very similar amount. And the Neweer one is slightly bigger, so it makes sense that it would weigh more just because there's more plastic, at the very least. So I wouldn't be surprised at all if these had the same battery pack in them, or the exact same size and form factor of batteries inside of here. I'm guessing flat pack lithium ion. There's a similarity and a difference I just kind of want to note on the back here. Not only are the labels in exactly the same place, which isn't shocking because where else are you going to put a label on the back of here, but they both have that notch on the same corner, and it looks like they have the same radius on each other corner. But of course, these V-mount shoes, what are these pieces called? Oh crap, I forgot. Anyway, these two pieces, these are metal, as they should be, and these are obviously slightly different. Like this one has a 1/4 inch and a 3/8 inch thread. This one doesn't. And in fairness, these do have two separate manufacturers listed, but they're both in Shenzhen, China. So it's quite possible they're sourcing most of these components from the same original factories. But of course, there's a shit ton of companies in Shenzhen and factories in Shenzhen, so not necessarily. Although another notable facet, I guess, is that they both have orange USB ports, which is really an aesthetic choice. So, you know, those parts might very well have come from the same place. And I would talk about the barrel plugs, but I mean, those are pretty generic. You find that style anywhere. All right, so next step, I'm going to charge both of these to 100%, and then I guess tomorrow I'll discharge them both on the Keithley, get readings on their capacity. Because that's end of the day what I'm really concerned about. Now, capacity is one thing, charge-discharge cycles and general longevity is another thing. I'm not too concerned about that because I use V-mount cameras periodically, but not like every day, which is why I'm going for the cheaper batteries, not the really high-end professional ones. So I'm not too concerned with cycles. What I am concerned with is capacity. As long as the capacity doesn't diminish very quickly after just a few uses, and maybe I'll put these through a few charge-discharge cycles to see if their capacity goes down over the course of a few of them. But sometimes if their capacity is going to dip, it might not happen for 100 charge-discharge cycles, and how they're stored. Because lithium-ion batteries do not like being stored fully charged or empty or near empty. Empty for lithium-ion batteries, depending on the chemistry, being like around 3 volts. Like discharging to 0 volts will probably ruin the battery. Since these can charge off USB, I'm going to go out on a limb and say that these have charge controller chips on them, or battery controller modules, or whatever, to prevent overcharge and overdischarge. So like even when one of these reads 0%, each cell that's in here will most likely be at like 3 or 4 volts, depending on the chemistry. Well, anyway, enough waffling. Let me charge them up, and we'll get to the testing. And I'm just charging them off USB-C because I kind of feel like that's how they're meant to be charged, because these are consumer devices. Most people aren't going to have a proper like V-mount charger. So I would probably realistically charge these off USB-C. And this one is at 12%. This one's currently at 6%. Oh, and actually, how much wattage are they consuming for charge? Okay, so the Neweer, this has also a very dim display. So you have to take my word for it, because I'm not going to change the camera angles for now. But they're both consuming about 60 watts. The Neweer is consuming 60.7 watts, and the SmallRig 58.8. And that one's at 20 volts, and I'm assuming the other one is too. Yeah, and they're both charging at 20 volts. This power supply can output 100 watts per port. Well, actually, the first port can do 140 watts, and it's 250 watts total across all ports. So these two could both charge at 100 watts off of this power supply. They're choosing to charge at 60 watts, which is probably reasonable. Because charging a battery too quickly with too much current can also damage the battery over time. A lot of times you might hear that come into play with electric cars. Like if you fast charge an electric car every single time you charge it, that will shorten the lifespan of the batteries. Whereas if you charge it more slowly, longer lifespan. And the last thing I'll say at this stage, I know I said enough waffling, but I can't help myself. I'm sorry, guys. These are both 99 watt-hour batteries, ostensibly, because that's what it says. So in theory, from 0%, roughly, if these are going to actually supply, like I said, the battery won't be at 0%, but if these are actually going to supply 99 watt-hours to the user, they should take about 99 watt-hours to charge from 0. And they're not quite at 0, but it's charging at 60 watts right now. So in 1 hour, that will put 60 watt-hours into the battery. So it'll take a little over an hour and a half to max out these batteries, give or take, because it was approximately 60 watts. And there's going to be some losses going from 20 volts through whatever circuitry's in here to the battery voltage. I mean, I guess 2 hours, just for round numbers, is probably a good estimate. So anyway, I'll let these go and I'll be back. So I'm done with testing. I ran these both through a few charge and discharge cycles, and I measured the watt hours and amp hours going into them and coming out of them. And this is the setup I used. Multimeter, electronic load for discharging. I discharged through the DTAP connector because the DTAP connector is, I believe, directly connected to the batteries, not through any kind of battery management chip or any kind of voltage regulation. So that's a direct battery output. Here it's reading 16.19 volts or thereabouts. And for charging, slightly different thing. I used USB for charging, which, as it turns out, comes with a decent amount of overhead because it converts the 20, 15, or 9 volts that this is outputting. It does change voltages as it gets closer and closer to full charge. That then gets stepped down or up to the battery voltage as it charges. So there's a lot of losses in whatever controller chips are in here or whatever voltage conversion chips are in here. So therefore a considerable amount more watt hours went into the batteries and then came out. The reason I'm not too concerned about that being accurate is because the discharge is really what I'm concerned with. How much power can I get out of the battery to actually use? I don't really care how much goes into it necessarily, except that I wanted to compare both these packs to see if it was similar, which it was, meaning that both of these two packs are very similar. I still think they're pretty much identical other than some cosmetic and port location differences. And I'll show you the details, well, right now. So here we've got a not very fancy spreadsheet, but the Neweer battery I discharged 4 times and charged twice while measuring it. That's why it doesn't make sense. I charged it once off camera. And the Neweer I discharged 4 times and charged it twice. I know that doesn't seem like it makes sense. I charged it a couple of times off camera. And the SmallRig got 3 discharges and 2 charges. Again, 1 charge off camera. And for the charging, you can see that going from 0 to 100%, it was 107 watt hours going into the battery for the Neweer, 107 for one of the charges, and 109.09 for the second charge. I think that's probably just because it discharged a little lower the last time. Could have been a measurement issue, I'm not sure, but these numbers are extremely similar, so the battery should have roughly the same capacity, and the charging efficiency should be roughly the same. But of course, it's the discharges that we're really interested in, and what I found was these have about, we'll give them the benefit of the doubt and give them the highest number. This has a 92.63 watt hour capacity, not the 99 watt hours promised. Same with the SmallRig. A little bit of variance here, more so than the Neweer. I don't think that's a test methodology issue. I think that is a charge issue where the charge controller was shutting it off perhaps a little earlier or a little later. And for example, charge 3, which corresponds to discharge 3 here, you can see a little more energy went into it than charge 2, and so more energy came out. But the time the charges discontinue is based on the internal controller in the battery pack, whereas the discharge is coming, like I said, right off the battery itself. Amp hours, while informative, is not as significant as watt hours, because if you're using this with a camera, so that camera is going to need a certain wattage to run, a certain amount of power, and it'll have its own internal voltage converters. So the battery voltage, you can see, starts closer to 16 volts and ends around 11 volts. So if your camera's demanding a certain wattage, it's going to be drawing fewer amps up front and more amps at the end when the voltage is lower. But watt hours is the total power. That's really what you should be concerned about with any battery that doesn't have an absolutely stable output voltage. That being said, lithium-ion batteries tend to start... Actually, let me bring up a lithium-ion battery curve. Yeah. I'll just click on this one for simplicity. I don't know, strictly speaking, how accurate this exact graph is, but this is the general idea. That's correct. That the voltage falls off very quickly then it's fairly stable for most of the discharge, and then it falls off very quickly, which is what I saw with these battery packs. And as you can kind of see here, I did record all the charges and discharges, kind of just so that we could see if magic smoke came out, or the battery melted down. I'd get that on camera at a full frame rate, not just like stop motion. But we can see here, this is sort of during the middle of discharge. Voltage is 14.8-ish. And if we skip forward about 20 minutes, it's at 13.7. So it fell off a little, but not hugely. It wasn't that steep downward curve. And then if we look towards the end of discharge, you can see now it's at 13.6 volts. And then if I skip forward about half an hour, and with this clip at the end of discharge, you can see it's at 11.85 volts. I have the test set to end at 10.8 volts. So if we skip forward just about 4.5 minutes, you can see like it fell from 11.12 volts down to 10.8 very quickly. You can see it dropping a lot faster than it was. And this is at a 3 amp constant current discharge. So it started high at 16-ish volts, but then rather quickly dropped down to around 14 volts, slowly dropped down, then eventually fell off quickly from like maybe 13 point something down to 11. But anyway, the overall point I'm trying to make is that for your camera or other device that you might be running off of this, watt hours is more important than amp hours, especially if you're using like the D-tap connector. And I did track the times. At 3 amps of output, the Neweer lasted about 2 hours and 10 minutes, give or take. And this test was at 4 amps, hour and a half, hour and 37 minutes, really. But you can see the watt hours are the same, or roughly the same, whether it was discharging at 3 or 4 amps, which is what you'd expect. Now, if you discharge at a super high current, that might cause the battery to heat up, which might make it less efficient, and you might see a drop in watt hours. I picked 3 amps because that's a little bit under 0.5 C, because these batteries have a capacity of about 6.5 amp hours. So 3 amps is a little less than half that. It's just sort of a safe area I felt to operate in without pushing the batteries too hard. For the SmallRig, I did all of its discharges at 3 amps. They ended all about the same voltage, and the watt hours are a bit different. Again, I think that's because of charging, but you can see best case 93.65 watt hours. So based on the similarity in numbers, I'm inclined to believe that these battery packs have the same batteries in them, and based on the similar power consumption while charging, probably the same charge controller chips and voltage regulators in them. So the be-all and end-all of that whole spiel is that the Neweer costs significantly less than the SmallRig, has the same features, the same basic display. I actually like this one better because it displays all the information on the front, not just a percentage, for example, when charging. And that information includes battery voltage as well as the USB-C input voltage. Not mission critical that you have that information. I just think it's better to see that than a battery percentage, although this does also show the battery percentage. So I think the Neweer has better firmware and the same capacity as the SmallRig. So buy the Neweer if you're going back and forth between these two. I did want to mention that, to their credit, I dropped both these on the floor from the table on 2 separate occasions by accident. They went maybe less than a meter off the table down to a concrete floor with a thin vinyl tile on it. So not very cushiony, but no damage whatsoever. And just by way of comparison, here is a more commercially grade lithium-ion V-mount battery pack. And this does have the same capacity. This is rated 14.8 volts, 6.6 amp hour, and you can see the size difference. If I had to guess, this probably has cylindrical cells in it, and this has flat pack cells, which probably explains why this is a little thicker and this one's a little taller. And they're both, of course, roughly the same width. And this has a fairly dummy but useful LED indicator for charge status. The reason I bring that up is because this one just feels like less brittle plastic. You know that, and this just has a thinner, cheaper, more, I know it's not the right term, plasticky feel. Meaning, like, I'm surprised this didn't break when it fell on my floor. And of course, you might be, accidentally fumble this battery off of a tripod where your camera's, let's say, 6 feet off of a concrete floor. I don't want to try it because I do want to use these batteries. I mean, I want to use both of them, even though I kind of wish I bought 2 Neweers because it would have been cheaper at this point. But yeah, I don't trust this not to break. if it fell 6 feet, whereas this one probably wouldn't. Though that is just speculation on my part. Like I said, I don't want to risk ruining the batteries. I'm sorry if you were hoping for that. This isn't going to be a destructive test. And just to give you a flavor of what happened during the testing, this is a time lapse of the Neweer being discharged and the SmallRig being charged. And it always took longer to charge than discharge, even though the average power on discharge and charge was about the same. The charging was a lot less efficient because it had to go through a voltage regulator. And I took some thermal images of it too, and you can see that the battery under charge is a lot warmer than the battery under discharge, even though it's actually charging at a lower current than the discharge. And that's partially due to the internal chemistry of lithium-ion batteries. They'll heat up more during charge than discharge. But you can see there's a lot of heat by the USB-C port, and that's likely because of the voltage regulator in there, or DC-DC converter, as the case may be. And one other thing I wanted to show is that I'm monitoring the voltage of both the 12 volt out and the 8 volt out barrel plugs. The reason for that is I wanted to see what happened, especially to the 12 volt output, as the battery voltage dropped below 12 volts. Because surely it's using a voltage regulator or voltage converter to drop the battery voltage from 16, 14, whatever volts down to 12. But I didn't know if it had a boost circuit as well to boost the voltage back up to 12, and it does not. As the battery voltage dips below 12, so does the voltage on the 12 volt output, and they happen pretty much in step. That being said, I mentioned earlier I had the discharge test set to cut off at 10.8 volts, and that's because these battery packs surely have 4 lithium-ion cells in them. And we can infer that because the max charge voltage for a lithium-ion cell should be 4.2 volts, maybe push it 4.3, and we were seeing 16.5-ish, 16.6-ish when it was at full charge, which is roughly 4 volts, I'll put it on screen, this. And the minimum voltage to which you should discharge a lithium-ion cell, I've heard differing opinions on this, and it depends on the exact battery. The manufacturer will publish the minimum discharge voltage, but figure it's about 2.5 to 2.7 volts, and 2.7 seems to be the broadly accepted answer. So 2.7 times 4 for 4 cells is 10.8 volts total, which is why I set the discharge cutoff at 10.8 volts. And realistically, the voltage fall off at the end is so steep that even if I set it lower than that, let's say to 10 volts, it really wouldn't have squeezed out much more in the way of watt hours. In fact, in the very first discharge test I did, I set the cutoff voltage to 12 volts just to be ultra safe. And then I went, you know what, let's go a little lower than that. So just to be on the safe side, I looked up the minimum discharge voltage as best I could find it for these batteries, not knowing exactly what they are, and went to 10.8. And you can see between 12 volts and 10.8 volts, it only discharged a very small number of watt hours. And so at 3 amps, that's also a very short amount of time. But discharging it lower than that would risk damaging the battery. Which brings me to another point. I mean, like I said, the D-tap output comes... actually, you know what? And the one thing I forgot to check is even though the D-tap connector comes right off the batteries, it may have over-discharge protection. Like, that may be going through a MOSFET or something, and it may be it is definitely monitoring the output voltage on the battery. So right now, this one is at 12.53 volts under no load. I'm going to draw 2 amps from it because this battery is empty according to its internal monitor. It's hard to see, but it's at 0% right now. So it's fully discharged. I'm going to try to discharge it a little more. And I currently have the cutoff on the Rigol set to 9 volts, which I really don't want to go any lower than that. But, you know, for science. I also don't feel like sitting here forever. Let me bring it back up to 3 amps. And while that's going, I want to talk about this weird cable right here. Oh, okay, it just said battery test completed, which means it already hit 9 volts, of course, as I was adjusting the camera. Well, now here's the problem, though. Did it hit 9 volts? It only got 0.365 watt hours during that brief discharge. But I'm just wondering, did the battery cut that off? Because if I unplug this right now, it will say the test completed. Oh no, it dropped down to 9. Like, it really fell off from 11 straight to 9. If I set the current, let's say, to 1 amp, that might occur a little more slowly. I know this isn't an ideal setup. I wasn't planning on doing this test right now, but like I said, for science, we should find this out. Yeah, I think that was the battery pack's internal management shutting it down, actually. So I think it does have under voltage protection, because I didn't see this crash down to 9 volts. And so we can see discharging it even more. We eked out an extra 3 minutes and 30 seconds of runtime at 1 amp, and that discharged an extra 0.669 nice watt hours. So even at a lower current, that's not pulling the voltage down quite as much at the end. In theory, maybe you could get another, 0.669 watt hours out of this, maybe just another watt hour. But either way, this is not really that close to the 99 watt hours they promised in any of these tests. If we were hovering around the 99 mark, if it was 97 or 98, I'd be more inclined to be polite about it and say that this isn't a lie, but this appears to be a lie. It's not 99 watt hours. And I believe my test methodology was fine. I should show you this cable that I made explicitly for this test. So this has a D-tap connector on one end and obviously 4 connections on the other end. These 2 thicker wires are for the load. This is what's actually passing the current. And these 2 thinner wires are just for voltage monitoring. And the 2 red wires are tied together at the back of the pins in the D-tap connector, and same with the 2 black wires. And the idea being this way we're monitoring the voltage before any drop along the length of the cable. Now, there is really not much in the way of voltage drop on these wires because this is 14 gauge wire. I was pulling 3 amps through it. Not much is going to get dissipated in these wires as heat. Every wire, I mean, if I had superconductors down here, I'd be doing much fancier stuff. But every wire is going to have a resistance over its length. The longer the wire, the greater resistance. Thinner the wire, the greater resistance. All other things being equal. And so on this very short run with this 14 gauge wire at roughly, let's say, 14.8 volts nominal, we're not going to get much in the way of voltage drop. And therefore, the wire itself is not going to be consuming much current. It's certainly not going to account for that difference between 99 and 92 watt hours that we saw. And I only did the last 2 discharge tests for each battery using this cable. I did the first few discharge tests using this cable where I didn't have any spare D-tap connectors at that point. I bought a few of these. And so I just snipped the end off of a D-tap cable that had a barrel plug on it, stuck 2 spade connectors on it, and there we go. But you can see this wire is much thinner, and so it should have a higher resistance. The thing is, when we look at the figures, there's not really much in the way of difference between discharge tests 1, 2, 3, and then 4, where I used the thicker wires. Point being, I'm fairly confident in my discharge methodology. I've used that Rigol electronic load for a lot of stuff, and especially with the more accurate voltage monitoring, I'm pretty sure that what we have here is correct. And the starting voltages when under load were roughly the same regardless of which cable I use, where this was monitoring the voltage after any voltage drop along this cable. And really the only thing this will ever be useful for is for testing any batteries or devices that have a D-tap output. I'm not going to get into this right now because I'm going to make a separate video about it. I already recorded it. I just have to edit it together. But I made this wild cable, which is very similar to banana plugs and to spade connectors. Actually, they're ring terminal connectors, but very different function. These 2 that go to the banana plugs are to monitor voltage. These 2 blue ones, well, they're blue because it's not for a load, it's for a current shunt that's in the back of this piece of equipment, and the current flows through these blue cables looping back to these connectors being USB-C. And I used this to measure the power drawn during charging because it has the ability to measure watt hours as well as amp hours. And that allowed me to loop the USB-C power supply in one of these connectors and then out the other one to the battery. So that's how I did the charge measurements. But like I said, I'm not judging it based on the measurements I made while charging because the power that went in on charge is always going to be higher than the power on discharge. So it was really just to satisfy my own curiosity and see if the two batteries were really similar. But anyway, if you're interested in the construction of this ugly cable and why it's ugly, check out that other video, which may be out by the time you're seeing this. And just in case anyone was curious, these are the notes that are on the spreadsheet. This first discharge test I did 12 volts, and then from 12 volts to 10.8, and that only gave an extra 5 minutes and 15 seconds of runtime at 3 amps. And as I said earlier, the 12 volt barrel plug output dipped below 12 volts tracking with the battery. The 8 volt output remains stable until the end, so those just have voltage converters that can step down, not up. And then you can see this last discharge test was done with that new D-tap connector cable that I made up and just showed you. And same deal with this battery pack. Discharge 01, I just didn't monitor the 12 volt output on that one, which is fine because that should behave the same regardless. Like that's not a test that really needs to be repeated. And obviously all charges measured via USB-C, so it's inclusive of voltage converter losses. And that's the voltage converter in the battery packs, not in my USB-C charger, because I was measuring the charge current and voltage on the USB-C port. Anyway, that was a long video to make, both because the charge and discharge cycles took over 2 hours each time, and because I stopped to make a couple of custom cables, and also just faffed around doing other things in the house. So it's been a few days since I shot the first part of this video, but yeah, my ultimate verdict is these are just fine. Buy the Neweer, not the SmallRig. Not because either one is bad, just because it seems the SmallRig is priced much more highly than the Neweer. If that changes, if the SmallRig becomes less costly, buy the SmallRig. They're both fine. I mean, I have no real complaints with either of these battery packs. The only thing we haven't tried them with is an actual camera. So let me do that before we wrap up. A little front heavy, but battery should take care of that. Let's try the Neweer first. Mechanically, it slides on very nicely. Well, obviously we do have power, and there we go. You can see my washing machine there in the background. This isn't really going to show off my great camera work, but yeah. Battery voltage 16 volts. Let's stop that down a little bit. And yeah. Alright, that was the Neweer. Camera seemed to like that just fine. SmallRig. Oh, I'm an idiot. I'm so stupid. The SmallRig is fully discharged. Oh man, that was dumb. Yeah, the SmallRig just went through a full discharge. So I'll test this after charging it. If it worked fine, it worked fine. If it didn't, I'll pop back into the video with an update. If I didn't pop into the video with an update and the text on screen said it worked fine, let's go with that. So yeah, that's the story between the Neweer and the SmallRig, both 99 watt-hour battery packs. Anyway, thanks for watching. Sky can roll a bribe, and you know, YouTube, that stuff. Later.